Hi everyone. In this video, I will explain how to find a remainder by using congruence modulo m. So before taking PYQ, you see the definition for congruence modulo m. If a comma b are integers, m is natural number, then a is said to be congruent to b modulo m. If a minus b is divisible by m, that is mathematically represented as a congruent to b modulo m. Simply, a is congruent to b modulo m provided if a minus b is divisible by m. See one example. 46 is congruent to 11 modulo 5. What is the reason? 46 minus 11 is 35. 35 is divisible by 5. Also see, 46 is congruent to 1 modulo 5. 46 minus 1 is 45, divisible by 5. See one more, 46 congruent to minus 4 modulo 5. 46 minus of minus 4 will become 50, 50 divisible by 5. See this 1 is the non-negative integer less than 5. Therefore 1 becomes remainder. That means when 46 is divided by 5, remainder becomes 1. This minus 4 is said to be negative remainder. To convert that negative remainder into non-negative remainder, just add 5. Minus 4 plus 5, that becomes 1. So to do problems related to congruence modulo m, we have to remember these properties. If a congruent to b modulo m and x congruent to y modulo m, then the properties you see by adding them. A plus x congruent to b plus y modulo m. By subtracting them. A minus x congruent to b minus y modulo m. By multiplying them. Ax congruent to by modulo m. No division. Fourth one, see, multiplying both sides with some integer. Ka congruent to kb modulo m. K is integer. Raising power k, a to the power of k congruent to b power k modulo m. So you have to remember these properties. Now let us take one PYQ, how we can calculate remainder. I will explain. The remainder when 64 power 64 is divided by 7 is equal to dash. This problem was given on April 7th, 2025 in shift 1. How we can calculate the remainder? By using congruence modulo m. See now. The given number 64 to the power of 64 whole power 64. So that is in the form of a to the power of m whole power n. That is a to the power of mn. That is 64 to the power of 64 into 64 I can say. That is the given number. So when this number is divided by 7, I have to calculate the remainder. See, I can write 64 is congruent to 1 modulo 7. Why 64 is congruent to 1 modulo 7? 64 divided by 7. 7 9 ja 63, remainder is 1. Therefore, I can say 64 is congruent to 1 modulo 7. Now I am taking whole power 64 into 64 on either side. 64 to the power of 64 into 64 is equal to congruent to 1 to the power of 64 into 64 modulo 7. So by using this property, I wrote that step. 1 to the power of 64 into 64, you know, it is 1. So this is congruent to 1 modulo 7. So 1 is the non-negative integer less than 7. Therefore 1 becomes remainder. That means 64 to the power of 64 whole power 64 divided by 7, remainder is 1. See now which option is correct option? So B option is the correct option. This is very simple to calculate a remainder with the help of this congruence modulo M. See one more model on congruence modulo M. Let capital A be a matrix of order 3 by 3 and determinant of A is equal to 2. If n is equal to determinant of adjoint of 2024 of A, then the remainder when n is divided by 9 is. This problem was given on January 31st, 2024 in shift 2. This is numerical value type, answer is 7. So there, when n is divided by 9, we have to calculate the remainder. See how we can calculate. So first I am calculating n value. N is equal to determinant of adjoint of 2024 of A. So we know formula. This can be written as determinant of A to the power of n minus 1 to the power of m. Determinant of A becomes 2. Order of the matrix is 3. 3 minus 1 becomes 2. M representing the number of adjoints. The number of adjoints are 2024. So this power will become 2024. That is the value of n. So n is equal to 2 power 2024. When that number is divided by 9, we have to calculate the remainder. Because divisor is 9, I want to convert that base as 8. When 8 divided by 9, remainder becomes minus 1, so that we can calculate remainder very easily. So I want to convert that base into 8. To convert that base into 8, that exponent should be converted into the form 3 lambda plus k. So when the exponent is converted into the form 3 lambda plus k, 2 cube becomes 8, base can be converted into 8. Now see how I can convert the exponent in terms of 3 lambda plus k. Let us consider 2 is congruent to minus 1, 2 is congruent to minus 1 modulo 3. So when 2 divided by 3, remainder is minus 1. Here exponent is 2 to the power of 2024. So I am taking 2 power 2024, that is 2 to the power of 2024. This is congruent to minus 1 to the power of 2024 modulo 3. Just I took power 2024 on either side. So minus 1 to the power of even number is plus 1. So this is congruent to 1 modulo 3. That means 2 to the power of 2024 divided by 3. Remainder becomes 1. So according to division algorithm, 2 to the power of 2024, this can be written as 3 lambda plus 1, division algorithm. Dividend is equal to divisor into quotient plus remainder form. Now let us consider n value. So n is equal to 2 to the power of 2 power 2024. That is 2 to the power of 2024. That exponent can be written as 3 lambda plus 1. Further I can say this can be written as 8 to the power of lambda multiplied with 2 to the power of 1. So 2 to the power of 2024 2 to the power of 2 to the power of 2024 can be written as 8 power lambda into 2 to the power of 1. So 2 to the power of 2 to the power of 2024, that is congruent to 8 divided by 9, remainder is minus 1. So it will become minus 1 to the power of lambda. 2 divided by 9, remainder is 2. This is modulo 9. So I wrote this number is congruent to minus 1 to the power of lambda into 2 modulo 9, because divisor is 9. Minus 1 to the power of lambda, that may be either minus 1 or plus 1, depends on lambda. So 2 to the power of 2024 is even number. On the right side we are having 3 lambda plus 1. 1 is odd, 3 is odd. Therefore lambda should be odd. Odd natural number into odd natural number, odd. Odd plus odd, that becomes even. Therefore here I can say lambda is becoming odd natural number. Because lambda is odd natural number, minus 1 to the power of lambda, that becomes minus 1 multiplied with 2 modulo 9. Minus 1 into 2 becomes minus 2. This is minus 2 modulo 9. Minus 2 is the negative remainder. To convert that into non-negative remainder, add 9. Minus 2 plus 9 becomes 7, no? So it is congruent to 7 modulo 9. 7 is the non-negative integer less than 9. Therefore 7 is the remainder. That means when 2 to the power of 2 to the power of 2024 divided by 9, remainder becomes 7. Here I am giving 2 PYQs on the same model with hints. Practice yourself. For more videos, subscribe.